Hey guys, today we are going to solve the problem add two numbers. Let's first read the problem description. We are given two non-empty linked lists representing two non-negative integers. The digits are stored in reversed value. Okay, that's important. And each of their nodes contain a single digit. Add the two numbers and return the sum as a linked list. Okay, let's look at the example. So here we have the digits 2, 4, and 3, and this list represents the number 342. Why? Because the digits are stored in reversed order. For the other list, we have the number 465. If we take the sum of these two numbers, we get 807, and for that reason, this is going to be our result. So how can we solve this problem? It's quite straightforward. If we are going to write two functions, and if we manage writing them, the problem is pretty much solved. The first function is going to be converting a list in this representation. So in the representation where the digits are stored in reverse order, and it's going to return the corresponding number. So for example, for this list, it's going to return the number 342. And for this list, it's going to return the number 465. Now, after writing this function, we are going to take the sum of the two numbers. We're going to get the result. And we are going to write one more function that takes a number, an integer as an input, and returns the list where the digits are stored in a reverse order. If we manage to do that, then we solve the problem. Now let's look at the logic behind the first function that takes a list and returns the corresponding number. So what do we know about this list? We know that the digits are stored in reversed order. And for that reason, we know that the first node is going to store the value of the ones. The second node is going to store the value of the tens. Third node for the hundreds, and so on. So all we have to do is iterate over this list with some type of counter that tells us, okay, in the first node, this counter is going to be equal to 0 because we want to take the ones, and that just means 10 to the power of 0. Second node, we want to increment this counter to 1 because now we want to take the tens, which is 10 to the power of 1, and so on. So basically, for the ith node, we want 10 to the power of I multiplied by the node's value. So that's going to yield the corresponding number. Now that we have the corresponding numbers for each of the lists and we added them, in this example we are going to get 807. So given a number, any number, in this case 807, how can we convert it to the corresponding list? Well, that's not too hard. We can see that just the same thing applies. The ones value is going to be the first node. How can we get the ones value? That's easy. We are just going to take the number modulo 10, which is going to give us 7, and it's always going to give us the ones value. And we are going to create the first node with the value 7. Now we want to look at the remaining of the number, so we want to remove this 7. How can we do that? We can divide the number by 10 and forgetting about the remainder, right? In Python you can do that with divide sign. So now we look at the next number and we want the next digit. So how can we get the next digit? Again, we are just going to get the answer modulo 10. In this case, it's going to be 0. So we are going to add 0 to our list. Now we again divide by 10 and we get the last number, the last digit. And we're going to take the result modulo 10, we are going to get 8. And when are we going to stop? Well, now when we divide 8 by 10, we get 0. So when we get to 0, we are going to stop. So this is how we convert a number to a list. And now let's move on to the code. There is one small thing that I will talk about when I'm writing the code, just one edge case to notice. And let's say about the time complexity. The time complexity is going to be just O of n, because first time we use the first function to convert a list to a number, it's going to be O of n operations. Same thing to convert the second number, and the addition is also going to be the same, because the sum of the two numbers is not going to be, let's say, more than a few times bigger than the bigger number of these two. So that's pretty efficient, and space complexity is O of n if you count the creation of this list, and it's actually constant extra space on top of the result, where you always have to create. As we said, the first thing that we are going to do is we are going to write the function that converts each list to the corresponding number. So I is the exponent, like in the explanation, and now we are going to iterate over the list, and each time we are going to take, in the first iteration, the ones, the tens, the hundreds, and so on. Okay, that's the first function. Second function is we are going to convert a number to a list. The logic is not too different, and many times in list problems you are going to have a dummy node, because it makes it easier to deal with some edge cases. So again, while num is bigger than 0, each time we're going to divide it by 10. And we're going to create a list node with the value of the least significant digit always. Okay, so what is this test? So first of all, dummy is going to be just a node before the list that we are creating. So for example, if we want to create this list 708, then dummy is going to be a node that points to 7. That's the first thing. That's why we want to return dummy.next. And why do we have to check if dummy.next is none? Well, imagine if both of the input lists were 0. So if both had just one node, which value is 0, then the resulting number, after we convert each list to a number, we get 0 and 0. The sum is always also 0. And now when we convert 0 to a list, then well, we are never going to enter this loop. So if dummy.next is none, that means we never enter this loop, and that means the result is 0, because that is going to be the only case where we don't enter this loop, not even once. So in this case, we just return a single node, which value is 0. So now that we have those two functions, all we got to do is first we want to convert both lists to a number, right? And we want to add those two numbers. And then we want to convert the number or the sum. We can call it sum, maybe that's a more appropriate name. And we want to convert sum to a list and return it. Let's see if that works. Okay, it does not. Let's see what is the problem. Line 25. Okay, now looks good. And as you can see, it's pretty efficient.